So imagine you're writing a script, right? You're setting up a JSON API to process like thousands of financial transactions.
Okay. High stakes right out of the gate.
Exactly. And, you deploy it, it runs smoothly. The system is reporting all these successful payloads. Everything looks great.
Until it doesn't.
Right. Because weeks later, you realize your parser was silently dropping the last 3 lines of every single transaction.
Oh, wow.
Yeah, just because of like a missing trailing bracket or something trivial. But the system didn't crash. It didn't throw an error.
It just quietly discarded the invalid data.
Exactly. It just sent back a 200 OK status code and permanently corrupted your financial records, which in the world of software architecture is basically the terrifying reality of a silent failure.
It's the ultimate nightmare scenario for a developer. I mean, a loud crash is an annoyance, right? You can fix that today.
Right.
But a silent failure is this, like, systemic rot that you might not even discover until the damage is completely irreversible. And what makes it so insidious is that developers often, inadvertently program their systems to fail silently, just in the name of convenience.
Which is wild to think about. But anyway, welcome to the deep dive. Today, our mission is aimed squarely at you, the listener, as we explore this really fascinating intersection between the highly technical world of Haskell debugging,
Oh, yeah.
the architecture of error handling, and honestly, the much more human philosophy of lifelong learning.
Yeah, we're looking at a very specific approach to preventing those silent failures today. And it's drawn from this just brilliant piece of technical documentation.
Yeah, so our source material is a blog post. It's dated March 25th, 2026 from keonmeng.org. And the site actually operates under this great subtitle, Musings of an Old Software Plumber.
I love that subtitle.
It's so good. But the specific post we're dissecting is titled Notes on Haskell Programming Part 91, Improving Error Visibility in Megaparsec.
Which, I mean, the title alone kind of hints at the depth of the material here. By the time someone reaches Part 91 of their notes on a, purely functional language like Haskell,
They're pretty deep in.
oh yeah, they have moved way beyond the basics.
Hmm.
They are wrestling with the really nuanced realities of production-level systems.
Okay, let's unpack this. Because while Haskell Programming Part 91 might sound a bit intimidating.
Million bit, yeah.
Right. Nominally, it's about fixing a single parser flaw. But the solution that Ang, the author, implements is just a masterclass in system design. And before we even look at the Megaparsec library, we really have to look at the sheer scale of the surrounding knowledge on this blog.
Because the context completely informs the code.
Exactly.
The metadata of this archive is just staggering. I mean, Ang has been documenting his learning since 2011.
Wow.
Yeah. And in March 2026 alone, which is the month this Haskell post went live, there are 75 distinct posts.
Wait, 75 in 1 month.
In 1 month. And if you pull back to the previous year, 2025, you see 730 posts. He's publishing these deep, technical or reflective essays twice a day, every single day, without fail.
Which totally defies the conventional wisdom of the modern internet. I mean, we are constantly told to niche down,
Right.
to build authority in one specific area.
Right, pick your lane and stay in it.
Exactly. But if you look at the sidebar of this blog, Ang is publishing notes on Haskell right alongside notes on fishkeeping part 217, balancing the goldfish,
Yeah.
and notes on gardening part 846, the ladder effect. He's actively documenting his deep dives into Wi-Fi 7 networks, artificial intelligence.
Dieting, photography.
Yeah, even the propagation of Brazilian spinach. So I have to ask, in a world that constantly tells us to niche down to avoid information overload, how does this author manage to keep all these plates spinning without getting completely overwhelmed?
What's fascinating here is that his approach to all these disparate subjects is governed by the exact same methodology. Like he says, he calls himself a software plumber. And that mindset scales infinitely.
Well, think about an actual plumber. A plumber doesn't try to, redesign the entire municipal water grid from scratch.
Right.
They isolate a specific valve, they diagnose a single leak, they tighten the fitting, they document the change, and then they just move on to the next task.
The power of discrete iteration.
Exactly. And he is applying that to everything. He's not trying to write the definitive textbook on functional programming. He's isolating one single behavior in a parser, fixing it, and writing part 91.
And then he does the same thing in the garden.
Right. He isolates one single variable in his garden's lighting setup, tweaks it, and writes part 846. He's building this massive interconnected lattice of knowledge, not by trying to master the universe right out of the gate,
But by mastering the very next pebble in front of him.
beautifully put, yeah.
And the specific pebble he decided to master on March 25th involved a pretty critical flaw in how he was processing data. So let's get into the mechanics of the Megaparsec library. Ang was building a parser, and he hit a wall because he was relying on a function called parseMaybe. Right. And for developers familiar with Haskell, you know that maybe is a core type. It's used to handle computations that might fail.
Okay.
It returns either a just containing a value or a nothing. So it basically forces you to handle the absence of data, which theoretically is much safer than dealing with, null pointers in languages like C or Java.
Sure. But in the specific context of Megaparsec, parseMaybe kind of creates this dangerous illusion of safety, doesn't it?
Oh, absolutely.
Because looking at Ang's documentation, when you feed a file into parseMaybe, it begins processing the stream. If it successfully parses a valid chunk of data, it returns just that data.
Yep.
But if there is a block of completely invalid, malformed garbage trailing at the very end of the file,
parseMaybe doesn't flag it.
it just stops. It stops at the end of the good data, returns the just value, and silently abandons the unconsumed input.
It completely swallows the error. I mean, the function technically did its job, right? It parsed something successfully. But from a systems perspective, it leaves the developer completely blind to the fact that their data source is generating this malformed trailing content.
It's like having an editor who reads the first good paragraph of your essay, says, hey, looks great,
Yeah.
and then completely ignores the fact that the last 3 pages are just random letters mashed on the keyboard.
That is the perfect analogy. And in software, and honestly in learning, a silent fail is the most dangerous kind of fail. Because if a system ignores invalid data, you lose the ability to understand why the data is invalid in the first place.
Yeah.
You lose what Ang calls error visibility.
Right. He couldn't fix the bad data because the parser was actively hiding it from him.
Exactly. Whenever a system accepts mostly right data and just ignores the fringes, the core problem generating that bad data remains unfluxed. We see this all the time, like when a sensor starts to drift or a third-party API quietly changes its response format.
Some tiny shifts.
Yeah, and if your parser is too forgiving, it just sweeps those anomalies under the rug until they cascade into a catastrophic failure somewhere downstream. And by the time that happens...
Good luck finding it.
Right. Tracing the rot back to the original silently dropped string is nearly impossible.
So, if parseMaybe is just sweeping errors under the rug, Ang realized it had to go. To restore error visibility, he swapped it out for a much more rigid combination. He used runParser alongside a function called errorBundlePretty.
Which is such a fantastic utility in the Megaparsec ecosystem. Because when a strict parser fails, you don't just want it to crash and give you some generic exception.
Right, that's not helpful either.
No. You want actionable intelligence. So errorBundlePretty intercepts the failure and generates this highly readable multi-line report. It tells you the exact line, the exact column, the token it expected, and the token it actually received.
So it turns a fatal crash into a highly precise diagnostic tool. But the real engineering challenge here wasn't just formatting the error, right? It was forcing the system to confront every single piece of bad data. He had to force the parser to actually traverse the entire file to find those trailing errors in the first place.
Right, because runParser alone, depending on how you write your combinators, might still stop early once it satisfies its primary rule. You have to explicitly command the parser to verify that the input stream is completely empty before it declares success.
Which brings us to the actual technical fix. Ang implemented the less than asterisk operator, the applicative sequence operator, followed immediately by EOF, which stands for end of file.
And understanding how that less than asterisk operator works mechanically is crucial. Not just for Haskell, but for understanding his whole philosophy.
Okay, let's break that down because the mechanics here are beautiful. In Haskell, you're dealing with pure functions, which means you have to be highly explicit about how side effects, like advancing a parser's state, are handled.
Right. When you sequence 2 parsing actions, you have to tell the compiler which result you actually want to keep.
Okay.
If you use the standard sequence operator, which is asterisk greater than, it evaluates the left side, evaluates the right side, and keeps the result of the right side.
Wait, so if Ang used the standard one, asterisk greater than, he would evaluate his parsed data on the left, evaluate the EOF on the right.
And the function would just return the EOF result, which is essentially an empty unit.
So he would successfully verify the end of the file, but he'd throw away all his actual parsed data?
Exactly. It would be useless.
Sure.
So he specifically uses less than asterisk. This operator sequences the actions, but it points the other way.
Okay.
It evaluates the parser on the left, then it evaluates the EOF on the right, It retains the value of the left side, the actual parse data you need, but it enforces the effects of the right side.
Meaning if the EOF check fails because there's like unconsumed garbage data left in the stream?
The entire operation fails
Yeah.
and triggers that error bundle pretty output.
Here's where it gets really interesting, though, because Ang provides an analogy in the source material to make this visual for the listener.
Oh, the grocery store analogy.
Yes. So think of the sepend by function, the core parsing action on the left side of the operator, as a cashier scanning every grocery item in your cart.
They are processing the valid data.
Right. Then think of the EOF function, the action on the right side of the operator, as the security guard standing at the exit of the store checking your receipt.
It captures the mechanism of that operator flawlessly. The operator dictates that both actions must execute in sequence. The cashier scans the items, and then the security guard checks the receipt at the door.
But crucially, you keep the result of the left action. You get to take your groceries home.
Right.
You do not keep the result of the right action. You don't take the security guard home.
No, the security guard is just a required boundary check. By placing the less than asterisk operator right before EOF, Ang is hard-coding this rule into his software. He's saying, scan all the valid data you want, but before this function can resolve, you must hit the true end of the file.
And if there's even one unscanned item left in the cart,
1 byte of invalid trailing data.
the security guard will stop you, block the exit, and trigger the alarm.
Exactly. The silent fail is entirely eliminated. No unscanned items leave the store.
But wait, I want to push back on this from an architectural standpoint for a second. Because from a user's perspective, or even an engineer's perspective, there is a famous principle, Postel's law, right? The robustness principle.
Sure. Be conservative in what you send, liberal in what you accept.
Exactly. So if I'm building an API and the payload has 100 rows of perfect data, but there's one stray comma at the very bottom, isn't it highly annoying when a program stops and yells at you over a tiny error at the very end of a file?
It is annoying.
So why not design systems to be resilient? Why not just take the good data, ignore the stray comma, and move on?
This raises an important question, and it really represents a massive philosophical divide in modern engineering. Because Postel's law, it made sense in the early days of the internet. Connections were fragile, protocols were super messy. But in modern, complex, distributed systems, being liberal in what you accept is often a recipe for disaster.
Because it breeds ambiguity.
It breeds cascading ambiguity. Let's say service A accepts slightly malformed data from service B. It might make assumptions to try and fix that data before passing it to service C.
Okay.
Then service C receives an unexpected format, makes its own assumptions, and passes it to the database. Suddenly, you have massive state corruption. And because every service along the chain was trying to be helpful and resilient,
Nobody logged an error.
nobody logged an error, you end up with a distributed silent fail. The alternative, what Ang is enforcing with his EOF check, is to fail fast and fail loud. Yes, in the short term, strict parsing is incredibly annoying. Your build breaks over a stray comma.
Which is frustrating.
Very. But by utilizing tools like Error Bundle Pretty, you mitigate that annoyance because the system tells you exactly where the comma is. It respects your time over the long haul. You take the minor pain up front to guarantee absolute stability later. You fix the pipeline rather than permanently band-aiding the lakes.
I love that. And if we pull back from the Megaparsec library and look at the broader context of qianmeng.org, you really start to realize that this technical solution is just one manifestation of a much larger worldview. It's this whole tapestry of tinkering.
Oh, totally. If we connect this to the bigger picture, Ang's demand for error visibility in Haskell is the exact same demand he places on his physical environment.
Like the gardening. Looking at the sidebar, you see notes on garden part 826. Leggy seedlings again. And, a leggy seedling, a plant that's growing too tall and thin because it's desperately stretching for light.
That is a biological error message.
It is. It's the environment's version of a loud crash.
And a less observant gardener might just, stake the plant up, which is effectively ignoring the bad data. They're applying the parse maybe approach.
Right. The plant looks fine for now.
But the root system is weak, and the core problem, the lack of light, remains completely unfixed. Ang, operating as the ultimate plumber, doesn't ignore the leggy seedling. He diagnoses the systemic flaw, adjusts the lighting distance, records the variable change, and documents it in part 826.
Or take his fishkeeping notes, part 206. simulating the monsoon season. You can't just dump cold water into a tank and hope the ecosystem survives. You have to monitor the temperature gradients, the flow rates, the behavioral changes in the fish. You have to create a system that forces you to confront the reality of the environment, not just your assumptions about it.
Exactly. Whether he's dealing with a purely functional programming language, a hydroponic setup, or a closed aquatic ecosystem, he is refusing to accept silent failures. He isolates the variable, he demands clear, actionable feedback, corrects the state, and writes it down.
So what does this all mean for you, the person listening right now, the person just trying to stay well-informed in a world that produces an overwhelming amount of data every single day?
I think the lesson extends far beyond code. It's really about auditing how you process information.
Yeah. Being well-informed isn't about consuming everything at once. When you are learning a new complex subject, maybe you're reading a dense research paper or trying to understand some highly technical policy, it is incredibly tempting to act like parse mocks maybe.
Oh, we all do it.
You read the abstract, you understand the first 3 paragraphs, and when you hit the dense statistical modeling at the end, your brain just quietly skips over it.
You silently drop the unconsumed input.
Exactly. You close the PDF and tell yourself, well, I got the gist of it, but you didn't. You accepted the good data and ignored the boundaries of your own understanding. If that unread section contradicts the abstract, your entire mental model of that subject is now corrupted.
So you have to build personal systems with high error visibility. You have to force the loud fail.
Trigger your own error bundle pretty. Stop reading. Acknowledge what you don't understand. Force yourself to recognize the invalid trailing parts. Highlight the confusing terms, and refuse to consider the subject learned until you've parsed the entire file.
And, part of building that system is adopting the intellectual humility that Ang displays right at the bottom of his blog. He includes this disclaimer that reads, "Opinions expressed here are my own. I cannot guarantee the accuracy or completeness of all information supplied here."
Which some people might just view as a standard legal shield.
Right. But in the context of a guy who has published thousands of essays documenting his own learning process, it reads very differently. It's a declaration of his methodology. He's explicitly telling his readers that he is not a flawless compiler. He is a work in progress. He expects to produce errors.
He's inviting the internet to act as his error bundle pretty.
Exactly. He wants the community to point out his stray commas and his flawed logic so he can patch his internal systems.
It just completely removes the pressure of having to be an infallible expert before you're allowed to share your work. The goal isn't perfection on the first pass. The goal is relentless, documented iteration.
You don't master Haskell or gardening or anything else by never making a mistake. You master it by making sure every single mistake is highly visible, highly documented, and immediately fixed.
We have covered incredible ground today. We started by stumbling upon this massive 15-year archive from a self-proclaimed software plumber.
Yeah.
We broke down why Megaparsec needed the error bundle pretty function and how silent failures in a parsing library can corrupt complex systems by just hiding bad data.
And we explored how applicative sequence operators force a system to confront its boundaries.
Right. How the less than asterisk operator paired with EOF acts exactly like a security guard checking your receipt at the door. You keep your scanned groceries, but no unscanned data leaves the store.
And then zooming out to see how that hyper-specific technical demand for error visibility is the exact same trait required to cultivate a garden or master any complex body of knowledge.
It's all about refusing the convenience of the silent fail.
Which leaves you with a critical, provocative thought to mull over in your own life. Think about your own daily routine for taking in information, whether it's reading the news, doing research, or sitting in meetings. What is your personal applicative sequence operator?
Oh, I love that framing.
Do you have a security guard at the exit of your mind? To check if the conclusions you're walking away with actually match the facts you just consumed? Or are you, like a lazy parser, silently ignoring the bad data trailing at the end of the meeting and just hoping for the best?
It really is the difference between feeling informed and actually being informed. Well, thank you so much for joining us on this deep dive. Stay curious, build systems that expose your errors, and keep tinkering. We'll see you next time.